Before we proceed into introductions, I will launch a quick poll, because for us panelists, it's very useful to know who is with us today. So please have a look at the alternatives there and pick the one that seems to come closest to your personal status along your RFID journey. I will keep the poll open, proceed to introductions. Starting with myself, I am Juho Partanen, the Director of Business Development here at Voyantic. Additionally, I am an elected director at the RAIN board, which may explain some of the preferred terminology that I'll be using today. A noteworthy piece of news for many of the familiar names I can see were with us. Today, Voyantic has become a Impinj company. We continue to run our business as a subsidiary and under the Voyantic brand. Continuing then to our true experts of the day, we have Mr. Chris Brown of TSC Printronix Photo ID, subject matter expert. Chris, very warm welcome to you. Very good morning. How are you doing today?
I'm doing well, thank you, and thank you for hosting this. And by the way, congratulations on joining with Impinj.
Thank you very much. Are you gearing up for your travel to the RFID Journal Live?
Good question. Yes, I will be there. We will have a booth, and we hope we see as many people as possible down in Florida at RFID Journal Live. That's next week already. Yes.
It is, and I am sure it's not going to be an empty hall. Then on to our second expert, a dear colleague of mine here at Voyantic, our Director of Sales, Mr. Teemu Ainosoja. Teemu, good to have you with us. How has your day been?
It's been a good day. A lot of things to do, but that's always a good thing. And also, I'm looking forward to meeting everybody at the RFID Journal Live next week.
There you go. Excellent. Good. Hey, thank you, Teemu and Chris, for being here. Before jumping into the RAIN RFID basics, let's have a look at the poll results. We can see most of the folks being already fairly well into the business, but we can see rookies, a couple of dreamers and bystanders in the crowd as well. We will most definitely want to make your time worthy today. So we'll most definitely cover the basics, starting with the next slide here. So RAIN RFID is a wireless identification technology that connects everyday items to networks and internet. Plenty of different use cases. We'll come back to that in a minute. But what makes RAIN fundamentally different from other identification technologies is that there is no need for line of sight. There's no battery in the tag. It's very low cost. So the delta cost of adding RAIN functionality on a package or an item is just a few cents. And again, highlighting the difference to some other technologies, a RAIN tag operates only in the presence of a reader device, as there is no battery. The use cases are numerous in different industry verticals, including retail, which has been the dominant market segment by far in the recent 10 years. But industrial manufacturing is also a big segment, along with rising stars like healthcare and pharmaceuticals. This technology really is present and in fact very much used in distribution centers, shopping malls, airports, and hospitals. The RAIN RFID use cases in practice, so how these tags are being read, There is manual scanning with handheld readers. There's advanced zone reading with overhead readers. We have point of sale, these unmanned self-checkout counters, transition reading, very traditional way of capturing the IDs that pass through a certain doorway, for example, also known as gate or a portal. We can also see robots doing inventories, and there's also these retail cabinets and smart shelves being utilized. RAIN technology is very high speed, so typically you can read hundreds of items within a second or so. Read ranges typically between the tags and the readers are several meters, even tens of meters, 20 feet easily. So it's very high performing technology. And EPC stands for electronic product code, or RFID emblem. Either one of those indicate RAIN functionality on an item or a hang tag. So those are used to indicate this technology is used. One of the core components in RAIN systems is the inlay, the structure. In a simplified way, you have an antenna on a substrate, and then you have a IC glued on top of the antenna. That forms a inlay structure. And some further terminology related to inlays. You have dry and wet inlays. The substrate traditionally has been PET, but paper is more and more often utilized nowadays. The inlays may be cut or uncut. You have also different types of labels, woven and care labels as pictured, and hang tags, obviously, that are widely utilized in retail, specifically in the US. For today's audience, many of you are probably interested in the Walmart initiatives. There, we often hear white wet inlay, also known as a sticker, being utilized as the term. You can see the sticker, also the white wet inlay on the picture. Then we'll talk more about the terms around inlays in a few minutes. Before handing it over to Teemu, I'll also cover the RFID market segment. Here, this graph came out from the RAIN Alliance a couple of weeks back, and it shows how the volumes of delivered RAIN tag ICs are on a rise. In 22, more than 34 billion tag ICs were delivered, which is quite a significant growth compared to the earlier year. And we are set to continue the growth. So we are in the right market. The technology is proven. In fact, tens of millions of Americans and Europeans working in logistics, distribution centers, and retail stores utilize this technology every day without maybe even thinking about it. So it is business as usual in many sectors, and there are new sectors that we have to look at, including fast food industry, logistics, healthcare, I mentioned earlier, and groceries gradually picking up too. Finding useful information can be difficult. Well, obviously I am in my own notorious Google bubble, but as I type in the keywords Walmart RFID mandate, this is what I get. None of the top 10 hits lead to a Walmart page. That is one of the motivational factors for us to produce this webinar to you all. So going through the basics related to the retailer mandates. And as more and more retailers get into the business and retailers expand tagging mandates to cover new item categories, there are several different things that label producers are doing to react on the increased demand. It really starts with acquiring information and knowledge. Second step, usually to expand supplier and partner networks. And finally, then the steps 3 and 4, looking at the production machinery. First, many upgrade the existing machinery. If it's possible to upgrade, that is done to support RAIN RFID. And as business continues to grow, then many companies invest in dedicated RAIN RFID production machines. And Teemu will come back to these steps in a few minutes. In fact, next up, Teemu will introduce the RFID manufacturing process. Please.
Thank you, Juho. In this section, I will go through the RFID label manufacturing process and how converting relates to the whole process. I will also discuss in general what the RFID label converting requires and what kind of things should be considered. The terminology around RFID manufacturing is not perfectly standardized, so it is useful to be familiar with the big picture, the entire process. This way, it is easier to avoid misunderstandings and notice when a question needs to be asked. For example, Juho described the term inlay and how that may mean different things: dry inlay, wet inlay, cut inlay, uncut inlay, paper-based inlay, and so on. And there are also situations when one thing can be referred to with many terms, such as white sticker, white wet inlay, blank label, which all mean in practice one and same thing. From a manufacturing process point of view, in the very beginning, there is component manufacturing, which is not visible in this slide, but ICs, antennas, liner materials, and so on, they have their own manufacturing processes. The first step in the actual label manufacturing process is chip attachment, or also known as IC bonding. And outcome of this process step is inlay, uncut dry inlay to be precise. IC bonding requires some specialized machinery and specialized skills, I would say. Usually only specialized inlay manufacturing companies do the IC bonding. Next, the uncut dry inlays are converted into one or more process steps. And some typical converting steps are, for example, adding adhesive and base liner, making the uncut dry inlay into a wet inlay, and then adding layers of materials on top, such as adding paper face for printing, so turning the wet inlay into white wet inlay or blank label. The materials also cut from the continuous string into individual stickers. There are a lot of opportunities or possibilities how the process goes in details. And some of those details would depend on what exactly needs to be the output. So what kind of sticker, also known as white wet inlay, also known as blank label, what needs to be produced? Then, after converting, sometimes made in same press and same process with converting, data is added to the blank label. We call this step personalization. Blank labels are similar to each other, and they are turned into individual ones by adding data, including the unique serial number, which is part of the RFID code. So in case of RFID, the personalization includes usually encoding, that is writing data to the memory of the label, and printing any human readable or machine readable codes and images. And then, not really part of the production process, but related, is tagging. The ready label is attached to an item, turning it into a tagged item. For a converting company, the opportunities in RFID are anywhere from uncut dry inlay forward. That is steps after the IC attach, up to delivering fully encoded and printed labels. I would say that the IC attach and attaching label to items are unlikely to be in the converting company scope. You can imagine that finding the right part of the process requires discussions with both customers and suppliers. So with customers, what will customer do and what they expect converting company, their supplier, to do? For example, who encodes the data to the memory of the RFID label? Who prints them? And what would be delivery format, such as what size of rolls should be delivered to the customers? And then there are discussions with suppliers, the inlay manufacturers. What should be purchased as raw material? Is it uncut dry inlays, wet inlays, some form of stickers, something else? And a lot of the details also depend on the capabilities of the current machinery and what kind of investments would be needed for adding some process steps. Take a next slide. As Juho mentioned earlier, demand for RAIN RFID is strongly growing. It is typical to start with some capacity and some capabilities, which are defined by the immediate customer needs. But scaling up should be kept in mind. Almost certainly, your first RFID label buyer customer will not be the last one. Some ways to scale up production are adding lanes to current machinery. Some components and machine types are challenging to upgrade and some are easier. For example, adding parallel inlay insertion modules or die-cut modules to existing machinery may not always be possible, simply because of, for example, space restrictions. But some things are easier. For example, it is usually quite easy to add more parallel lanes into the quality control systems. Another way is integrating several process steps to one machine. It tends to increase the capacity. A typical example would be to combine various steps of converting and personalization into one machine run. This process step combination seems to be more economical when production runs are longer. Shorter runs, they still require some adjustment between the runs, and they are often more economical with specialized machines. With specialized machines, there is higher likelihood of being able to run some process steps continuously or in long runs, and then you divide the process of production to shorter runs at the very end of the process. And ultimate of the combined process steps would be to combine RFID into item manufacturing. So instead of making labels, RFID would be embedded to the items. However, in the near future, more likely sticker alternative approaches would be to combine RFID to prime labels or packages, turning them into smart packages. This integration RFID to prime label or smart package is a step closer to embedding tags to items, but it's an easier step. There is less variation in machinery needed in production. And also, I would say that it's important that the skills related to RFID manufacturing would still only be needed at converting companies, instead of every manufacturer of every item in the world needing to learn the RFID. I brought up RFID quality control partly because that is what Voyantic does, but mainly because it is one of the clearly new elements when label converting is turned into RFID converting. So quality control QC of RFID is very different from QC of barcodes. RF cannot be seen. A label that works well usually looks exactly as a label that doesn't work as specified. So good and bad labels cannot be distinguished just by the looks. The testing must be done with RF. And also RF quality is not on-off, good, bad, as clearly. And RFID tag may be readable, but it's still not working as it should. The practical effect of quality is varying read range. That is, from how far can an RFID label be read with an RFID reader. If this read range is not as expected, or if the read range varies a lot, it would be a problem for the RFID label user. Testing and finding out what are the read ranges may sound complicated, but in fact, it's not. It can be done inline, so the QC can be done at production speeds, and the outcome is still sorting out tags that have lower than specified read range or that are somehow otherwise too different from the typical or normal label. We have a lot more material about QC on our website, and there is also a recording of an earlier webinar which was solely focused on the RFID QC. Now let's go on and check what is needed when RFID converting is started. Our starting point for this section is a situation where an existing label customer asks RFID to be added to their labels. And this may happen, for example, when a retailer tells to their supplier, a customer of a label company, a brand owner, about moving into RFID use. And then the brand company asks their supplier, which is the label converter, to add RFID into their labels. Quite often these requests or mandates mention some information sources such as Auburn RFID Lab or GS1. And there is often some terminology which we discussed earlier, like the EBC and inlay. Now, I would still imagine that at first there are a lot of questions, and a lot of them are about the big picture. What is RFID? What do I need? How do I get started? Who can I call? And in this section, me and Chris will go through some of the required things more in detail, with the aim of painting some view of the big picture. And a short list would be inlays that need to be sourced. Machinery is needed for converting inlays into a format that customer requires, and then this converting machinery needs quality control. Encoding and personalization is needed in some cases. This would depend on the customer requirements. If encoding needs to be done, encoding equipment is needed. And that encoding equipment can be, for example, separate hardware such as desktop RFID printers, or it can be encoding hardware integrated inline into the converting machines. Obviously, there are plenty of details on any of these, and with that note, I will hand the speech to Chris.
Thank you, Teemu. So I'm going to talk some about the terminology. Teemu has very correctly said that the terminology in our RFID world, much of it is not finalized, much of it is not consistent, but there are some basic terms that you should be familiar with, particularly in connection with the retailer RFID mandates that are starting to affect you. So the basic landscape here is that you are an RFID converter and your customers are now coming to you. They've been getting their labels from you for 20, 30 years. They're happy customers, but suddenly they are saying, whoops, hey, we love your labels, but now they need to have RFID too. So you need to start delivering your products to your customers with RFID. Most of those labels that you have traditionally been delivering to your customers have a UPC or EAN barcode on them. UPC is United States and Canada. EAN is basically the rest of the world. So the UPC EAN barcode, if I go to the retail store and I pick up some items, they all have that ubiquitous barcode. That's the UPC EAN barcode. In that barcode is a number, and what we're going to fundamentally do is convert that to an RFID encoding. But there's some lingo here that you need to be familiar with. So in the RFID world, if you're in Canada or the United States, you'll be dealing with UPC. If you're outside of Canada or the United States, you'll be dealing with EAN. But for RFID, think of them as the same. Those are both GS1 terms. GS1 is the global standards organization that monitors the numbers in those barcodes, controls the standards of those barcodes. And they have a third term, GTIN. That stands for Global Trade Item Number. GS1 wants RFID to be global. So instead of saying UPC number or EAN number, they're going to say the GTIN. So what you're going to be doing is encoding that barcode number, the GTIN number, into an RFID encoding. Teemu has mentioned the term EPC. That's going to be hitting you from all directions all the time. That is also a GS1 term. It has many nuances and different meanings, but for your purposes, I would think of it just meaning RFID or the actual number that you're going to encode to your tag. I mentioned the term EPC here because you're going to hear it a lot, and because most of the labels that you will produce for your customers will need to have the EPC logo printed on them. In some cases outside of the United States, instead of the EPC logo, they'll use the ISO RFID logo printed on the label, but the concept is the same. It's to advise end users that, hey, this product has an RFID label on it or in it. So I have explained that what you are doing conceptually is converting that GTIN number to an RFID encoding. That's where the term SGTIN 96 comes into play. This is a particular RFID, what we would call encoding scheme. And it's the scheme for taking that UPC EAN number, converting it to RFID, and adding a serial number. So in the term SGTIN 96, you can see GTIN, which if you remember is approximately synonymous with UPC or EAN number. And then that initial S is for the serial number. Remember, you're adding now a unique serial number to each and every label. And then the 96 just means all of this information gets encoded to 96 bits in your tag chip memory. It helps here to understand that there's a mind shift going on in the retail world. The retail world traditionally has focused on product type. For example, half-liter bottle, plastic bottle, Diet Coke. And that's as far as the identification goes. But what's happening with RFID now, we are uniquely identifying each and every bottle of that Diet Coke. We're doing that by adding the serial number. So there's a whole mindset shift going on. Keep in mind, this means that you have to make sure that each and every serial number is unique. The last term there, permalock, that's going to hit you too. Some people might say lock permanently or permanently lock or permalock. They're all the same thing. Actually all of the mandates I'm familiar with, they say that after you encode the data, you must flip a few switches on the tag and permanently lock the data so that users cannot change the data. So you need to remember permalock. There is an RFID command called lock as well. That, however, can be unlocked with a password and then the data can be changed. So in most retailer mandate cases, you will be required to permalock the tags. Next slide, please.
Chris, before going into the next slide, there's a question. What happens if I use 128 bits? How is that different?
Okay. You can use a gazillion bits. You can use as many bits as you want. But firstly, you just need a tag chip that supports it. The practical limit is 496 bits. The GS1, sorry to get deep here, the GS1 standards say the maximum memory size in this memory bank is 496 bits, but there are some ISO standards that allow you to go to an infinite number of bits. Remember that we are, for the retailer mandates, we are doing a specific encoding scheme, which is SG-1096. Under SG-1096, there is no encodings greater than 96 bits. Now, there are other encoding schemes out there that do use more than 96 bits, and you can do them, but you need a tag chip that supports that with memory. Okay, here we have sort of a decision tree. Remember, you're going to get this deck. We don't expect you to have a photographic memory of this decision tree process, but you're going to be faced with the fundamental question of okay, my customer wants RFID labels now. Which inlay or inlays can I use for them? To have a decision tree like this is ideal, but we need to understand the lingo that's used in such a decision tree. I'm going to focus mostly on the left side, the certified inlays side, which is the standard path for the retailer mandates. And you see some terms there such as Auburn ARC program, ALEC program, Spec S, Spec H. I'm going to touch on those in the next slide, please. Okay, so you're faced with this fundamental question, which inlay or inlays can I use? You're going to have ideally your decision tree, and or you're going to have a mandate that your customer has been given, and you're going to check that mandate and follow the mandate to figure out which inlays you can use. If the inlays are not specified by mandate, very often for particular industries and or applications, there will be de facto inlays in use out in the field. You would probably try to want to stay with one of those. How are these inlays selected for the mandates? Well, there is some kind of quality certification process. This is where Auburn University's ARC program comes into play. So Walmart, Dick's Sporting Goods, even Macy's, Nordstrom, they work very closely with Auburn University. One of the things that Auburn University's RFID lab does, they do many things. One of the things they do is they receive hundreds of different inlays from the different inlay manufacturers, and they test those inlays by application and environment. And They test, let's say they test 100 inlays for a particular application and environment, and they decide that, okay, these 70 all work well. So we are going to publish what we call a spec, an ARC spec, that covers that industry and application. And we're going to give that spec some kind of code name. If you look at the table at the bottom, this is actually a screenshot from the Walmart mandate. It's just for two particular subcategories of items, but you can see the column that says inlay spec. So the first subcategory of goods requires a W1 inlay spec, and the second category requires a W2 spec. On the right, you see the links, those web links. So you would click on that web link. It's going to take you to a page that's going to show you 60, 70 inlays that are all approved for use by your customer for their retailer customer. Okay, so this is the Auburn ARC inlay certification process that they call the ARC specs. Now, not all of the retailers and the mandates use Auburn. Some of them have their own in-house inlay specification processes. So you would get documentation from that retailer, and that documentation is going to say these particular inlays are allowed for these products, or use these other inlays for these different products. Okay, next slide, please. Now, conceptually, you know what you're doing as far as the encoding. Remember, you're converting that GTIN number to an SGTIN96. You now have your inlay figured out. Now you need to actually get your label construction together. There are different possible label types that you could be supplying your customer. Of course, prime labels that you work with all the time, hang tags. Teemu and Juho have talked about embedded tags or tags embedded directly in the packaging and so on. But there's one term you need to be familiar with, and that's sticker. So sticker has become the common term in the retailer mandate world. Basically means small white label, small white RFID label. If you go to those inlay specs that I was talking about in the previous slide, they'll show you the inlays that are acceptable, that are allowed, and they'll all list the dimensions of the inlay. In the inlay world, inlay dimensions are a big thing. These stickers are basically that inlay plus a simple white face stock placed over the inlay with a little border around it. And that concept has become a very common solution for retailer suppliers to add RFID labels to their products. So you, the converter, you'll have to produce a lot of these stickers. On the right side of the screen, I have two example stickers. These two examples are from the Walmart mandate. The top one is the common one. That's the kind of sticker that you need to use when the product already has the UPC or EAN barcode, which is most products. But in rare cases, the product does not have the UPC or EAN barcode. So you need to add that and usually some additional information to the printed sticker. So stickers. A little note of caution on all of the labels you would be supplying for these mandates. There's usually some text in the mandates that talks about the face stock and or the adhesive requirements. The caution here is that these mandates were not written by label people. So the specifications for face stock and or adhesive can be nonsensical. I've seen this a lot. So if you encounter that scenario, it's probably not you that's crazy, but you do need to dig in and find out what exact face stock and adhesive specifications you can use. Okay, so now you've got your printed and encoded label. unfortunately, your customer cannot simply start slapping them on their products and shipping them out to Walmart or Dick's Sporting Goods. Your customer needs to go through some kind of approval process first to make sure that those labels are encoded properly, they are in a proper position on the item, and they have the proper information printed on them. For Walmart, Dick's Sporting Goods, for most of the retailers, this label approval process is covered under Auburn University's ALEC program. The ALEC program is a formally documented sequence of steps that you need to go through to make sure that the labels are correct and usable. Once you get ALEC approval, then you can start slapping your labels onto the items. Not all of the retailers use the ALEC program, the Auburn program. Some of them have their own in-house label approval process. So your customer would have to send some labels and or some tagged actual goods directly to the retailer for pre-approval. Last term here I got is the GS1 tip. It's not very commonly known in North America. TIP stands for Tagged Item Performance Protocol. I've been talking about the Auburn approach. The Auburn approach, the basic perspective is that they are testing inlays. Do the inlays work? The TIP perspective, the basic perspective, is that they want to test items that are already tagged. That's why it's called Tagged Item Performance Protocol. I bring up TIP because it is used for some mandates in Europe, and it's starting to grow in North America, especially for food and pharmaceutical. So you may have to become more familiar with GS1 TIP in the future and start working with a TIP testing lab. That's it here. Thank you.
Chris, a couple of questions.
Okay.
Is a UID the same as the EPC? And if you could kindly cover UII as you go.
Okay. I'll start with UII because that one's a little easier. So UII stands for Unique Item Identifier. And think of UII as the ISO equivalent of EPC. So there are sort of two worlds of RFID people out there. I'm making it very simple here. There's the GS1 world, and I've been focusing on GS1 world and using GS1 lingo because the retailer mandates use GS1. But there's a whole other world of RFID out there that uses ISO standards and ISO terminology. And the ISO people use the term UII instead of EPC. Remember, EPC means electronic product code. UII means unique item identifier. So they're basically synonymous, but from two different terms from two different worlds. Then there's UID. UID, I got to make sure I get this. And there's also UDI, and there's also UIID. UDI, let's leave that one alone. That's primarily for medical device marking, both barcode and RFID. UID, if I've got it right, is a US government Department of Defense term for the unique item number that gets encoded. So there's overlap there. If you're using a GS1 encoding, it would be roughly the same as the EPC number. If you're using an ISO encoding, it would be roughly the same as the UII number. Sorry, long stuff.
Perfect. Thank you.
I'll add to the UID that it is also a term used in the NFC world for the unique ID of NFC labels. Again,
I don't know nothing about
different. Okay, in this section, we will discuss a bit more details what a converting company needs. And we go forward, we will use this picture as a framework to dig into the details and practicalities. First item or step is to find out information and to understand the information. So to turn the information into knowledge. Goal is really to understand what the requirement is, what the mandate really means, what is cast in stone, and where there is freedom to choose. As an example, sometimes the requirement may mention inlay manufacturer and model. And in that case, there would be nothing to choose. You just need to establish a supplier relationship with the specified inlay manufacturer for purchasing the specified model. But more often, reference is to ARC specifications or TIBP requirements, which Chris mentioned. And there would be several possible inlay suppliers with several possible inlay models, which would mean that there is more negotiation on getting the delivery started, but obviously also more possibilities. And pretty much in all of the details, there is plenty to understand and dig deeper. What is the format of the label to be delivered? Is it a sticker? Is it a prime label? Or could the format be decided between the label converter and brand company based on practicalities and economics? There are details about printing. What exactly needs to be printed? And where and in which format the data comes? Is it pictures? Is it strings of text or something else? There's details about encoding. For example, what exact bits needs to be encoded to the memory of the IC? Which standard is followed? Is it EPC or UII? An easy way would be to get a list from a brand owner, the label buyer, one code per label. Even then, there may be some things to clarify. For example, typically those lists don't give you the bits, the ones and zeros, but it could be either a string of hex codes or it could be some kind of standardized format, URL format, for example, discussed in the EPC standards. And then in the end, bits go inside to the IC. So some understanding of the data formats is needed. Also, it is possible that the converter would take more responsibility on the data. For example, a brand owner would just tell that this is our UPC barcode or EAN barcode, and we will need to turn this into RFID code according to this and this standard, and we need to add a unique serial number for each label. In this case, the converter should have a way to manage serial numbers and a way to convert the UPC or EAN barcode to a correct format of EPC code. Obviously, that would require something else besides just handling a list of codes. Chris mentioned the locking and perma-locking, and I'll bring it up again. It's something that should be discussed even if customer doesn't mention it in their requirements. This is because if data is not locked, anyone could change the data afterwards and in practice change the identity of the tagged item. And obviously, that could lead into all kinds of misuse possibilities. The standards that are referred to in the RFID mandates may be quite heavy reading, at least in the beginning. And that is why experts such as Poyantic or TSC Printronics are available to help in understanding their requirements and underlying standards. And again, back to Chris.
Okay, thank you. Now, Teemu has made it very clear that you really need to understand these mandates and the specifications. I strongly believe that the converters I work with, need to get this expertise in-house. If you don't, you will risk losing customers when you cannot answer the RFID questions or provide the right RFID products. So the basic point of this slide is get that expertise in-house. Now, a little comment here. I think all of the mandates are written in such a way that they specify that only the retailer's suppliers is allowed to communicate with the retailer and or the testing agency, such as Auburn University. And they make it very difficult for other parties to step in and try to clarify things. Well, that takes away your role as a value-added provider to your customers. If you have a good in-house expert, that good in-house expert will get past that armor, those barriers, and be able to communicate directly with the retailers, Auburn, whatever GS1 tip lab, and even GS1. So get a good expert in-house. Next slide, please. One of the key things that your expert will need to do is to handle those notifications from your suppliers that, hey, sorry, this particular chip and or inlay has been discontinued. Let's say you've been supplying one of your customers with RFID labels for 2 years. It's all been wonderful. They have regular recurring orders for those labels. A new order comes in and you then go to order some inlays from your inlay supplier, and the inlay supplier says, sorry, that chip was discontinued, so we discontinued the inlay. Your expert needs to be able to navigate that and come up with an alternative inlay/chip combination that will work for the mandate or the customer's specifications. I see this, and this happens all the time, so it's a very regular part of the RFID process. This is an obstacle. It's a difficult thing that you need to be able to overcome, but it's also an opportunity because many converters are not bringing this expertise in-house and cannot handle this discontinued issue. They don't know what to do. So they throw up their hands and give up, and then their customers start shopping around with other converters. So it's an obstacle, but it's also an opportunity for you to get new customers. And I think back to Teemu now. Thank you.
Thanks. Inlays have been mentioned quite a few times already, and it is the core component which turns a label into an RFID label. Most commonly, mandates define dimensions of the RFID label, so the final label, and specify RF performance of inlays, for example, by referring into these ARC RFID lab categories or GS1 TIBB grades. And typically, there is some freedom to choose. So several inlay suppliers may have several inlay models meeting the performance requirements with small enough size so that they fit inside the label. Another set of limitations may come from the converting machine capabilities. What size of rolls can be used? What is the roll core diameter? Should inlay input material be cut or uncut? Should be the dry inlay without the adhesive or wet inlay with the adhesive and base liner? All those practical matters may limit the usable inlay pool which is available to choose from. But when those practical things are sorted out, rest is down to negotiation. Price obviously comes in mind as a selection factor, but I have to stress that it is not the only one. There would be plenty of other things that should be considered. Things like delivery schedules, delivery terms, quantities, possibilities to scale up, support available from your inlay supplier, quality data of the inlays, and so on. I'll mention that if you Google Voyantic RFID tag buyer's guide, you will actually find a document that has a longer checklist of possible things to consider when sourcing inlays. I think that is useful document to check and go through when preparing the purchases and doing the inlay selection for your labels. Let's go to the next slide. From a converting machine point of view, in our experience, RFID inlays are mostly just another material. If the converting machine has insertion capability or laminating capability, if there is a die cut, those same components could be used also with RFID. So even if RFID is electronics, you don't really need anything weird like clean rooms for manufacturing RFID labels. There are a couple of things to point out though. If your incoming material is dry inlays where there is no material on top of the IC, ESD protection and tension control should be considered. There was actually a question in the Q&A about preventing IC malfunction, and a common reason for this kind of malfunctions is either too loose or too high tension. So if the tension on a roll is too high, especially in case of dry inlays, the pressure against inlay may crack the IC. And if the roll is too loose, the roll starts to slip and that can scrape off the ICs. Also, if the IC during the converting process presses with high tension against a roller, that may crack the IC. So the underlying reasons may be several. I would say that the first step to get into that problem is the quality control equipment. Because that will tell you real time when things start to go wrong. And when you know it real time, it is easier to find out what are the process parameters and process details that may cause the problems, and then you can actually fix things. But anyway, typically I would say that the ESD and tension control are not that big a deal. So if your machine has some kind of tension control, some kind of ESD protection, that would be most likely okay also for RFID. And if you start with inlay, which has material on both sides of the IC, so there would be some material layer also on top of the IC, most likely you don't need anything extra. When there is material on both sides, the inlays or stickers are already fairly well protected against ESD and these mechanical failures. Still, I would say that the quality control is a necessary new thing when you turn converting machine into RFID converting machine. It is an investment, but technically it is an easy one. Another point worth mentioning is that inlays are individual components instead of continuous uniform material. And because of that, positioning is important. So, for example, when you die cut labels which include the antennas, if you would cut the antenna, the RFID tag would not work anymore. Also, in many cases, the position of the inlay inside the label must be precise. So, as an extreme example, if you have a bigger label, inlay inside, and if the inlay position randomly shifts from one corner to another, that might not be acceptable for the customer, even if otherwise the RFID still works very well. And back to Chris again.
Okay, we're going a little over time, so I'm going to go quickly here. So Teemu and Voyantic have you now producing RFID labels on your machinery, and they have the QC processes in place, but now many of your customers are going to ask you also to encode the labels. Well, the utopian endpoint in our world is that if you look at that graphic on the right, those are everyday retail products. You probably produce a lot of labels like that already with the UPC EAN barcode. But the direction we're trying to go in the future is that all of those labels will also have RFID for all of your everyday retail items. We're not quite there yet, as we've talked about. We're in the evolution as we speak. In the meantime, this is not a sales pitch for RFID printers, but most, I would say all of the RFID label converters that I work with have multiple RFID printers. They use them sort of as an interim solution for the encoding needs. So until we get inline high-speed encoding, people are having to use RFID printers. They also use these RFID printers as the encoder for low to mid-volume stickers. Remember, stickers are the small white labels that can be used for the retailer mandates. Many of the converters are using the RFID printers as an encoding device for prime labels, for prime RFID labels. You just need to make sure that the prime labels can be physically accommodated in the printer. And normally I see these setups, they have an external unwinder behind the printer and an external rewinder in front of the printer. That allows them to work with much bigger rolls. I've seen at least 16-inch rolls being run through these printers with an external unwinder, rewinder combination. And finally, even when we reach that nirvana end goal of having your everyday products tagged, you're still going to need some short run service bureau type jobs for encoding. So you'll still need some RFID printers handy for that. Next slide, please. And that's it. That takes us to our Q&A. We apologize for going a little over.
Good job, Teemu and Chris. Thank you so much. And you did already cover some of the questions. We have additional ones left here. One of the questions we received is that a custom claim says that they have delivered batch of labels that have duplicate EPCs within. So I guess, Chris, what is a duplicate EPC and how can they prevent something like that from happening again?
Okay, so I'm hearing a literal question, which I will answer, and I'm hearing an implicit question, which I will touch on. So the literal question of somebody is encoding duplicate serial numbers, that has to be managed by your serial number management program. This goes back to you need some RFID expertise in-house. Part of that RFID in-house expertise is to have a serial number management program in place so that you do not encode duplicate serial numbers. Burden on you. The implicit question that I'm guessing is involved here is, how do I guarantee that my encoding device encoded the correct tag with the correct data? That's a big can of worms. You have what we call cross encoding. You have theoretically misencodings, and you have non-encodings in our world. Some tag just doesn't get encoded. I'll start with misencodings. I don't think those happen. I think those are fictitious, where I'm supposed to encode A, B, C, and instead I encode 7, 8, 9. I think that's not happening. I think people just get tags mixed up. Cross encoding is an issue. I'm supposed to encode tag A with some data, but I accidentally encode tag B. That is an issue. And the solution, the real solution, is QC from a company like Voyantic that confirms with optical that what was printed matches what was supposed to be encoded. And then there's non-encodings, which is a bit of an issue, but I haven't seen that in a few years. So duplicate serial numbers, it's technically impossible for an encoding device to encode the incorrect number. It's not technically impossible to encode the correct number to the wrong tag. Boy, I just confused everybody there. Serial number management is the literal answer to the question.
Very good. Thank you, Chris. There was a few questions on prime labels. Can I run prime labels through an RFID printer?
Yeah, and I touched on that. So the big issue with running prime labels through your printer is to just make sure that physically they can be fed through an RFID printer. So if you, the converter, have control over the physical format, the roll sizes of your prime labels, you can set them up to be used with an RFID printer for the encoding.
Very good. There was a couple of questions on machinery and encoding equipment. So taking one from Josh, Timo, what is the status of tax assurance with encoding?
Oh, I just sent a reply to Josh on the QA window that we will send some more information through email.
Very political answer there. Thank you very much.
So the basic question there is, when do we get high-speed inline encoding on prime label presses? It's coming. That's the evolution.
It's coming, but details are not yet publicly available.
Okay.
Very down-to-earth question here. My customer has a specified dimensions for my RFIDs together with a certain tag IC. Now, as that particular tag product is end of life, am I okay to simply switch over to another label with the same dimensions, but with a different IC?
I can
Chris,
take that one.
Mm-hmm.
Yeah, this goes back to your in-house expert. So your in-house expert is going to have to determine what your customer was encoding, therefore what memory requirements will be needed in the new chip. Your customer might have been using an advanced chip feature, unlikely but possible, such as encryption. If so, then the new chip will have to support those advanced features. And your expert's going to want to know, is this a label from a particular mandate? If yes, give me all the specifications of the mandate, and then I can theoretically just go and check that mandate for some alternate inlays and chip combinations. And
Good.
very often that expert will also want to go back to the inlay company and say, hey, we know that this one's being discontinued. What's the replacement? And is it approved for a particular mandate already, or will it be?
Good. Still continue with a few questions and also a few additional links on the slide there for you. Dimitri is asking if you are supplying under the ARC grades, are you allowed to upgrade inlays, say from W1 instead of W2, or do these have to stay within a specified category?
Yes, they have to stay within a specified category. Now, there's a lot of overlap between the categories. You can find the same inlay in 5, 6 different categories.
And someone was asking for the web address for the list of inlay selection criteria. Don't think we have a specific web address for that. Instead, these different programs have their own addresses, but the selection chart that Chris briefly showed will be available to you in the slides that will be delivered in a few days. Maybe just a few other additional questions. Can we encode text on blank RFID labels? Yes, depends on the phase of material, whether you can print anything on that.
The question is, can you print on the blank RFID labels?
Yes.
Absolutely, yes. So you could either theoretically do it in the future in your fancy prime label presses, or as sort of the interim solution, use an RFID enabled printer, which simultaneously prints and encodes the tags.
Teemu, you are muted.
We lost your audio.
Yeah, you lost your audio. Hey, we are 10 minutes past the hour. Thank you very much for all of you that were on live. Thank you for those who watched the on-demand version later on. We appreciate your time very much. If you have feedback, we'd love to get that, since that helps us out while we produce the future webinars. For today's efforts, I'd like to thank Chris from TSC Printronics Auto ID and Teemu from Voyantic. Additionally, the marketing side, Hannele did a great job in promoting the webinar. Thank you all for your efforts and time today, and we look forward to seeing you in the future webinars.
Thank you, everybody.